Okay, hi friends, Andarki. Today we are going to discuss normalization concept in database. Uh, this is the topic of DBMS, that is database management system, in which uh, actually we know that the in a database the data is allotted in like rows and columns. Okay, so from this to understand easily the queries. Queries means to retrieve the data from the tables we write, as we discussed earlier in the SQL commands and the EMP table video. Please verify that if you have any doubts in that. Today, for normalization, it is, for example, from this table, we write year diagrams. Okay, year diagrams. From those year diagrams, we design a relation schema. Relation schema to design from relation schema from here diagram, it includes 7 steps. Okay. Now, in relation schema, what happens is it forms many tables. It forms many tables, like many tables of relations. Okay. Like these many relations will be formed. If we see clearly the attribute which is present in this table, for example, this is A and this is B. The attribute which is present in the A table, for example, 4 attributes are there. In these 3 attributes are there. The attributes which are present in the age table, some of the attributes, for example, this is 1, 2, 3, 4, 1, 2, 3. Okay, 3 attributes. These third attribute and this fourth attribute are again present in this table, this relation. Okay. Uh, if we convert these year diagrams to relation schema by using these 7 steps, then we will get this entire relation schema with many relations based upon the given table and year diagram. So, it mainly includes spurious data, spurious data, that is redundant data or duplication of data. Why I am saying duplication means, see, here whatever the column is there, same in this relation also it is present. So what is the use of that? Loss of memory or waste of memory is there. So to overcome these kind of data, okay, these two are going with this. To overcome this duplication, we are performing normalization. Okay. If we remove this duplication, we get a well-defined structure of relation schema. Okay. To get this well-defined structure of relation schema, we perform from normal forms. I will explain you in this tutorials. From normal forms, that is the process. This process is called as normalization. To eradicate or to overcome the duplication in the relations, we perform normalization. Okay. The main agenda is to remove the unwanted data or to give a well-defined structure to the relation schema or to remove the duplication of the data, like attributes duplication. This is called as normalization in simple. In simple, you may write it as giving a well-defined structure to a relation schema of any database is called normalization. Okay, this is the main topic, and we will go to next paragraph. Okay, that is normalization. What happens in the normalization background? I told you from the table we design. Wait, I will give you this. From the table we design ER diagram. From ER diagram we write relation schemas. Here it includes 7 steps. And from this relation schema, here I told you that duplication of data is there. And some of the anomalies also we will discuss. Anomalies means Problems. Anomalies means problems or difficulties in the relation schema. So we'll all discuss that. To overcome those, we will design another relation schema after normalization. Same relation schema only there, but after normalization, without keeping duplication of data or anomalies or the spurious data, we write relation schema after normalization. This is the final stage. Okay. Now, this is the background of normalization, why we use normalization, and definition of normalization we will discuss, why it is used also, what are the types of anomalies, what are the types of normalization, explaining all types of normalization, an example for understanding normalization, conclusion. Okay. We will discuss step by step. Next, what is normalization? Process of organizing the data in a database. Okay, this is also one definition. And write another definition. Okay, I will write here and I will keep it. Given very structure to the relation schema for any table or database. Okay, which reduces redundancy. Redundancy means extra attributes or columns in a table. Uh, and improves data integrity. Data integrity means it is a type of security or binding the data. Okay. If unwanted data is present in each table, this it does not follow the integrity. Integrity means in a less time, the query should perform more actions in a less time and give efficient work. So this improves data integrity and reduce redundancy means extra attributes within the relation schema. As I told, two tables, there two will be replaced in this. It will reduce that. And process of organizing. Organizing means, as I told, like this is relation A and relation B. Here four are organized. Here three attributes are organized. Like this. Organization is this way. Okay. This is about what is normalization. Next. Why we use normalization? Why? To avoid data duplication. Okay. As I told, two relation schemes prevent anomalies. Anomalies means mainly problems. Problems while constructing relation schema. That is, those are insert, update, and delete. As I explained. Ensure consistency. Consistency means A, B, C. This attribute and this attribute are present in this. What is the need to have duplicates? Okay. Consistency means if we break this relation, these two are in this part and these two are also in this part. So we will remove or eradicate this because already these are present in this. Okay. This improves consistency and gives well-defined structure to the relation scheme. Okay. And I will tell about anomalies. Anomalies means problems. Problems facing during insertion or updation or deletion into a relation database schema. Insert means when we insert the data into the A relation and another relation that is B. Okay. For example, this column is also present in here. This is also present in here. Okay. Now, if we insert the data into the A relation, then there is an anomaly or there is a problem because this is present here and here. Okay. So we should definitely enter the values into here also. This improves or this results to the duplication of the data. Okay, that is the insert anomaly. And update means, for suppose here roll number is there. Okay, roll number is there. Uh, if we add another, or if we update the existing roll number, for suppose if we take roll number 280, 280 was out of the column. He went out of the column. In that place, we should add another roll number. Okay, and something to 83. Okay, if we update this, this column is also present here. If we update here, we should definitely update here also. Uh, uh, Updating the values in the both the relations is waste of time because duplication is occurring. So to remove those, we will apply normalization. That is update anomaly and delete is also same like that. If we want to delete a record or delete a data in this column, same here also we should delete. Okay, this is here also deleting and here also deleting results in delete anomaly, delete problem. Okay, these are the anomalies. In simple words also you can know insert means inserting a value in the both the tables with the in presenting in the duplication like that. You can understand. Next, types of anomalies as I discussed. Insert means a problem occurred while inserting in the both the relations resulting to the duplication in simple. Updating means updating in the both the tables for same data for same column. It results in update anomaly because at updating the two relations with the same data, it results duplication and inconsistency. Okay. And delete anomaly, while deleting, it should be removed in the both the tables, same data. What is the need to delete same data? So we use some normalization techniques and remove these anomalies from the relation database schema. By removing these, duplicates also deleted. If duplicates are deleted, the database may get consistency. If we achieve these both, this is the well defined structure of a relation database schema that is called normalization. See, I am going like a tree structure from starting from here, going there and coming here. The ultimate goal is the relation database schema is free from duplication of data and anomalies. These are the main 2 points. That is called normalization. Next. Okay, we have to perform these two actions. What? To remove duplication and to remove the anomalies. Okay, to perform this, we have actually I told that normalization means to give a well-defined structure. So to achieve this, we have one first normal form, second normal form, and third normal form, and another is BCNF, that is boycott normal form, we will call it as. We have fourth and fifth also. Those do not play much importance, but first, second, third, and three. BCNF is also called as 3.5 normal. Okay, these four normal forms are very most important. Okay, these four normal forms very important. By using these four normal forms, we will convert the relation database schema which contains duplicate data and anomalies to which the relation data schema which do not contain duplicates of normal. Okay, this is the types of normal forms. We will discuss each one in here. Okay, coming to first normal form. See, first normal form means we will also discuss an example. No multi-valid attributes. As we are having attributes in the relation schema, attributes means columns. Okay. No multi-valid attributes. Multi-valid attributes means if A is there, A determines. Okay. A determines. If A there is like this arrow is there, this arrow represents determines. Okay. See this A that is LHS side will determine B and C. Okay. Now. there should be no multivalue attributes. See here, one attribute is determining B and C, B comma C. Okay, this is multivalue attribute. I will explain in a tabular form. Don't worry. Each field contains atomic values. Atomic values means single values. Okay, single values. This A is there. A should not have A1, A2, A3. Okay, this A should not have A1, A2, A3. Only it should determine only one column or one data within the relation database schema. Okay, I will explain an example. If we take roll number, mm, marks, qualification, okay, 280, 287, here 99 out of 100, here 92 out of 100. If we take the qualification is B.Tech and 12. Okay, here only the qualification is 12. If you consider this table, see here one roll number, here single roll number is a primary key because for each particular candidate, roll number will be not same, roll number is identical. So here 280 is having qualifications as B.Tech and 12th, but 287 is having only 12th. See here the qualification is having two values. So this is the multi-value attribute. Okay. So 280 is having two qualifications. That is multi-value attributes. For a single roll number, two qualifications are there. Two data is there. So this is multi-value attributes. So this is not in one ad. So there is one first normal form. It is not in first normal form. To make it first normal form, 280, like this you write 280 B.Tech and 280 12. So like this, we divide the data into then it is in first normal form. Okay. See here. One roll number is having duplication of data. That is B.Tech and 12. That is multiple attributes. To remove the duplication, we write B.Tech and 12 in a separate record. Okay. This is the process to convert a first normal form to first normal form. The relation database schema, which is in first normal form, to first normal. Okay. 287 is no problem because it is having only 12, only single data or single value. But here, multi-value should not be there. So this is a multi-value. We remove the multi-value. Okay. This is simple. Next, going to second normal form. Second normal form. Uh, it must be in first normal form. The basic primary goal for the second normal form is it should be definitely in first normal form and no partial dependency. Right. I will explain about the dependencies. Dependency. Uh, Dependencies are totally six types. We use partial dependency and transitive dependency. I will explain next. Next third normal form it will come. We will use only these. We will use only partial and transitive dependencies. So I will discuss about these two. Now coming to partial dependency means, see, partial means something it is depending on only one thing. Okay, only I will explain an example. A, B, C, D. See here, A is primary key. Okay, primary key we will determine with an underline like this. B is depending on A. Okay, D is depending on A, but C is depending on B. But every attribute in a relation database schema should depend on the primary key available in the database. Okay, relation database. But this C is depending on B. So here the A B, C, D. C is depending on B and remaining all are depending on A. So this is the partial dependency between A, B, C. B determines on A, C determines on B. This is the partial dependency. Okay. To remove this partial dependency, that is only the second normal form. There is no partial dependency. Before we're telling that the given data relation database schema or functional dependencies are in the second normal form. We should be careful that there is no partial dependency. And the database or the relation schema which was given or the functional dependencies which are given, it should be must be in first normal form. Okay. Then to remove these partial dependencies, first ABC is one relation and ABCD is one relation because D is not only depending on primary key. This is our requirement. Make sure that all the available attributes in a relation database schema should depend on the primary key. Here the primary key is A. Okay. To remove this partial dependency, we use R1 of A, B, C. A is depending on B, no problem. But B is depending on C. So first we will let R1 of which attributes are depending on A, B and D. So R1 of A comma B comma D. And which is not depending on primary key. That is R2 of C is not depending, but it is depending on some other. That should be right. The C is depending on B comma C. Okay. In this way, we should divide the relations. Now see, B is depending on A and A is depending on A. You may get the doubt that here B is depending on A and C is again depending on B. Here we may observe partial dependency. No, we should not think like this because the what the relation schema will tell is, see, now these relations are divided into two types, R1 and R2. Now we should check. We should not check like where from this. From this relation, we should not check now. Only up to now, what is the relation is available with us, we should check on that only. Here R1 is having A comma B comma D. We should only check within the A, B, D. What is the relation on which it is dependent. We should not include R2 in R1. Okay, we should not R2 in R1. Do not include. If you include, again, the question on all procedure will be wrong. So we should not include R2 and R1. After dividing the relations, we should see each relation differently. Okay. R1 is what it, these relations are available. R2 what is still available. So many will get doubt in this only. So be careful. Okay. Now, final we will write R1 of A comma B comma D, R2 of B comma C. Now the relation is what relation is what R of A comma B comma C comma D. Okay. This relation is converted or decomposed. We will use a term called decomposed in normalization. So this is decomposed to two relations that is free from partial dependency. That is no partial dependency. This is the format or procedure to remove the partial dependency in any relation data schema. Okay. And mm, you all should get one doubt. I had taken A as the relation primary key. Okay, A as the primary key. Primary key means which do not allow duplicates and which do not keep the database null in the particular column on which the primary key is applied. You may get the doubt why I choose A as the primary key. I will explain how I choose the primary key as A. They won't give this is the primary key or this is the primary key. We should find the primary key. Okay. Uh, by saying it is a primary key, we will call the term as candidate key. See, candidate key means, see, candidate key means a set of keys. which uniquely identify a particular data within the table or particular records within the table or relation. Okay, I will explain. Candidate key means which identifies uniquely. That is, see, group of primary keys gives candidate keys. Okay, group of candidate keys will give super keys. Super keys means it is a subset of candidate keys. For suppose candidate key, if we get A itself a super key, A with B is also super key, A with ABC is also super key. When if these two are also candidate keys, okay, all super keys are not candidate keys. All candidate keys are super keys. Okay, this is most important. Once again, I will repeat. All the candidate keys are super keys, but not all super keys are candidate keys. Okay, if it is not a candidate key, it will be a super key. Okay, because it is the combination of a candidate key. Because A is a candidate key which identifies uniquely records within a relation or table. The combination with any attribute with this candidate key is a super key. Okay, it need not be a candidate key. Okay, like that's it. That we will call a subset of candidate keys. Okay, next we will I will tell you. See, to find the candidate keys, as I told, because we will not keep much focus on primary keys. We will only keep on candidate keys because we should identify the candidate keys within the relation database schema, and then we should perform this 2NF, that is partial dependence. Because as I told, A, B, and this C and D. B is depending on A. Why it is depending on A? Because here A is the candidate key. First only if I say candidate key, you confuse means confused. So I told it as primary group of primary keys. It gives candidate keys. Okay, no problem. So directly we'll learn about candidate keys. If you know candidate keys, the problem will be very simplified. If you use primary keys and compute means for what? If what? Uh, this is also primary key. Okay. The sentence which I am telling is, if you consider these two as primary keys, it is meaningless. So, in place of that, we will use the candidate keys. Okay. Candidate keys means a set of keys or the minimal set of keys which is used to identify uniquely the specific records of data in the table, within the table or relational schema. Okay. To find the candidate keys, directly they want you. This is the candidate key, perform normalization. We should only require to find the candidate keys. So we will use closure. Closure is a special process introduced to find the candidate keys. We will learn about it. Okay. Closure. Closure. It is determined with star or plus, where if A is an attribute within the relation schema, A plus or A hashtag. Okay. These two will give, these two are the notations for closure. If you can change the attributes, no problem, B, C, D, but this symbol is mandatory. Okay. If we write A is equal to if we are doing closure also, if we do not mention this symbol, the process may go wrong. Okay. Should the symbol has more importance because to differentiate normal and closure, there must be an notation, right? So use this A plus. Maximum use A plus because A plus is familiar with all. Okay. Now we will find closure R of, first we will take one relation, R of A, B, C. Here I told functional dependencies. Those are partial dependencies and class dependencies. In second normal form, we are using partial dependencies. Okay. In question, in exam, how they will give is R of A, B, C. In exams means in B.Tech semester exams or gate exams, this is also more weightage or any exams related to the B.Tech database or in interviews, placements, definitely they will ask questions. So don't worry, you keep more concentration on learning this normalization. R of A comma B comma C. Okay, this is the relation schema which we have. Now they will give functional dependencies or dependencies. We call it as functional dependencies as A of B C. Okay. See here, we taken an example. R of A comma B comma C comma D is a relation schema, relation database. Now given functional dependencies are A, B, it determines, we call it as determines C and A determines D. These are, first we will check this is in a first order form or not. As these are atomic values, atomic attributes, A and B also atomic attributes. How to check atomic attributes means obviously the given function dependencies are already in first normal form because they mention A is having multiple attributes or B is having or C is having or D is having, then we should change them into first normal form. Okay. In general, all the functional dependencies which are given to be normalized to 2NF or 3NF or 3.5 NF, they are given in 1 NF only. That's for sure. So directly we perform from second normal form by writing a statement called it should be in 1NF. So it is in 1NF. We will write and we will start doing our second normal form process. Okay. If it is not in second normal form. Now, AB determines C and A determines D. Now, I told first we should find the candidate keys. For finding the candidate keys, we should perform closure on the attributes. Okay. First, I will tell a simple trick. Listen, what is in the left hand side? A, B, and A. First, we perform for them closure. How to find closure is A, B closure is equal to. Okay. I am telling the procedure. Like this, you write, right? And if AB closure we are finding, then self-determination. That is A comma G. Self-determination means which are determining they will come at first. This is the axioms or Armstrong's axioms. We call it Armstrong's axioms. Okay. Which attributes are determining in the closure finding? We should write them first. A comma B comma. Now, from the functional dependencies, AB is determining C. So, right here C. Okay. But again, check. If single A is determining anything. Yes, single determining A is determining something. So, we should write it C, comma D. Okay. D is not determining anything. So, remove as is it. No need to write. C. Our relation contains A, B, C, D. For finding AB closure, we got all the attributes. What I told candidate key. Candidate key means it identifies the attributes within the relation database schema uniquely. Okay. If we use this candidate key, we can determine all the available columns or attributes within the relation database schema. Okay. So this we consider as candidate. Therefore, candidate key is equal to AB. Okay. First one we got. Now A is there, single A. We find candidate closure of A. Again, I will explain how to find closure. Self-determination is most important point. It is the axiom of Armstrong. Okay. A plus A self-determination means A will come first and check and then directly go and check in the functional dependencies. Is A is determining anything? A is determining D. Okay. This arrow represents determining. A is determining D and then check if D is determining anything. No. Determining means it should be in the left hand side. Left hand side D is not there, so it is not determining anything. We should not stop here because combination of AD is determining anything. We should check. Here AB is determining, but AD is not determining. If AB, if in the place of D, B is there, if we will consider if C, I will tell. B is there, we will consider this AB and write C. Okay. Even though like this also it is not because D is not determining. Okay. So here A closure means A comma D. C and B are not determined. So A plus A closure or A plus is not a candidate key. Okay. Because A is not uniquely identifying all the attributes present in the relation. Okay. So it is not candidate key. So obviously we got the candidate key is AB. We will now check. Uh, Partial dependency means this is the process of finding the closure. This is most important. How to find the closure? Okay, one second. And now partial dependency means remember that our candidate key is AB. That means see these A, B, C, D. I will write here A, B, C, D. Candidate key is both A and B. So all the attributes see, I will tell. There are two concepts, prime and non-prime. Okay, prime and non-prime. Prime means this candidate key will come under prime. See here I will tell A and B both are there. The combination is a candidate key, but according to self-determination rule from Armstrong's axioms, A and B we will split it into two parts, and if ABC is there, we will split A comma B comma C. Okay, primes are A comma B, and other than these candidate keys or other than these prime attributes, all are considered as non-prime attributes. So non-prime are C and D. C comma D are the non-prime attributes. So what I told in partial dependencies means how to check this C must depend on A and B. Both it should depend. And this D also should depend on A and B. Okay. If D is depending on C, it is partial dependency because only should depend on the candidate keys or prime attributes. Okay. This is the main logic. Once again, I can explain. See, these two are candidate keys. So we split it into two and we call it as prime attributes. Every non-prime attribute should depend on every prime attribute, not only one prime attribute. For example, if C only depends on A but not on B, it is a partial dependency. Okay, it should depend on all the prime attributes. If D is depending on C, it is not because C is not a what? Prime attribute. It is a non-prime attribute. Okay. Now we will how to check whether which is depending on what. From functional dependencies, we will check. Okay. After writing this prime and non-prime attributes, go to functional dependencies. For easy way, like this, you write A, B, C, D. What are given in the relation. Now, A, B determines C means C is depending on A and B. Like that, you should read. A, B determines C means C is depending on A and B both. So there is no partial dependency because see in exam also you draw like this. There is no confusion between second normals. And the A determines D means D is depending on A. First you write, don't confuse. This is the diagrammatic or graphical approach for the given functional dependencies in the second normal form. So once observe that B is depending on A but not on B, but C is depending on both. Okay, because these two are non-prime attributes, these two must be depending on every prime attribute. But D is not depending on B. So here the problem arises. That is what our problem? Partial dependency. D is not determined on B, not dependent on D. So we arise a anomaly. Anomaly or problem, that is partial dependency. To remove that, we should perform second normal form. Now understand ultimate goal to remove this, to remove the partial dependency. That action we perform is called second normal form. We will remove step by step. Now R1 of first you write this way is simple. I will tell the simple way. Take two relations because one there are two prime attributes. Okay, I will tell simply, and two non-prime attributes. In the two non-prime attributes, one non-prime attribute is satisfying the condition. That is depending on both prime attributes. But D is not satisfying. So the attribute which is satisfying write in one relation, and the attribute which is not satisfying write in another. If E is there, E is also same doing like D. Then take another relation R. Okay, divide. After dividing, why we are dividing? I will tell. See now R1 of A comma B comma C. These three are one set. Okay. Next, R2 of, and now check. D is depending on what? A. So dependent and dependent. Both we should include. See, this is the initial relation. We have decomposed. As I told, the technical word decompose we will use. Decompose into two relations. This is this is free from second normal form. Why it is free from second normal form? I will tell. After dividing it into the relations, consider checking of second normal form, that is whether it is in the partial dependency or not, in the form of individually. Now these two are separated. Oh, check the partial dependency separately. Okay, don't mix up both. Separate partial dependency checking for R1 and separate for R2. Now check. C is depending on D and C is depending on A. Okay. D is depending on A. Okay. Okay. But we should not think that D is here also A. Again, partial dependency is K. Not. After dividing it into relations, this relation is separate and this relation is separate. We should examine partial dependency or any functional dependencies based upon individually. Okay, this is the most important point. We should check the partial dependency or any functional dependency individually after dividing it into different relations. Okay. Now this is free from partial dependency. So therefore, we may conclude that the above relations are in second normal form. Okay. Now upon going to next normal forms, we will consider only these relations. This is not. But we will use functional dependencies, but only will consider this one. Okay. Because it is having a problem in second normal form. If we go to third normal form, it must be in the second normal form. Okay. So you want to tell this is in the second normal form or these two are in second normal form. Obviously, these two are. So we'll use these two in the next coming third normal form. I understand you all understand this topic well. So we will go to next third normal form. Okay, third normal form. See, third normal form is the relations which are decomposed in previous second normal form. There should be must be in second normal form. Why I am stressing this point means if the relation is in first normal form, we should not directly perform third normal form. Okay. In between, we should perform second normal form. That's why I am stressing this point mainly. In second normal form also, I told it should be in, definitely should be in first normal form. That is. Okay. We are talking about third normal form. Let us continue. Okay. Third normal form. It should be in second normal form. Second normal form means it should be free from partial dependency. Okay. Now, R1 of, we got R1 of A comma B comma C and R2 of A comma D. Okay. These are two relations. Now, as usual, in every step, if there is any use of candidate key, we should only take AB only. Okay. And as usual, I told prime attributes are A comma B and non-prime attributes are C comma D. Okay, these are common, but this is most important. Okay, the definition of candidate key also most important, as I told previously. Now, what the third normal form is says is it should be in second normal form and no transitive dependency. Transitive we may learn in the mathematics. Okay, transitive means if A is determining B and B is determining C. Okay, that is plus A will also determine C. A will also determine C. So we should remove this kind of properties. Then it results in the formation of third normal form, which we require. Okay. Now we will see if there is any transitive dependency in there in this. Okay. The functional dependencies we also check. AB determines C and A determines D. Okay. Now see that. So these are the functional dependencies which you have in before. So once clear, listen. As I told, super key. Super key means it is a subset of, is a collection of all subsets of candidate keys. Here, AB is the candidate key. The keys which are found with AB, for suppose ABD is a super key, ABC is a super key, AB itself is a super key. Like that. The subsets of, we should add C and D because these are present in our relation. Because R of A, B, C, D. We should not add E because E is not there in our relation. Make sure that. Okay. I will tell in short. Wait. A super key should determine. See, LHS is super key and RHS is any attribute within our relation or given in the functional dependency. A super key should define an attribute, okay, which is present in our relation database scheme. Super keys means it's a subset of candidate keys, as I told AB, ABC, ABD, like that. Okay. Next, this rule which it follows, then it is not in transfer dependency. For example, previously we have gone through that. AB determines C, A determines D. This is not. This is in third normal form. This is satisfied third normal form because AB is determining C. Okay. As I told, AB itself is super key. Okay. Transitive dependency will observe. Transitive means if X determine if X determines Y determines Z, then obviously X will determine Z. But here AB determines C, but C is not determining anything. So this is free from transitive dependency. Because if C determines for suppose A, then obviously AB will determine A. Then here transitive dependency will occur. So this is not there. So AB is itself determining C. So this is free from transitive dependency and it is in third normal form. This functional dependency is third normal form. In coming to A comma A plus D, it's always is obviously it is in third normal form because A is determining C, D, but D is not determining anything. So A won't determine anything except D. So it is also free from transfer dependency. Therefore, it is also 3NF. So entire given function dependency is third normal form, is in third normal form. So our requirement is also third normal form. If what if it is not in third normal form, we will take an example. See the example. See the example I will take for understanding the third normal form. Our candidate key is A. Our relation is A comma B comma C. Okay. If functional dependencies are A, B and B, C. See, A, this is one relation and this is one relation because it should be in second order form. See, what is second order form? A is candidate key, B must be dependent on candidate key. It is dependent. But C is depending on B. So we should, it is not depending on A. So we should include in the another relation, separate relations. Okay, now it is in second order form. The first two point satisfied. Now there is no transitive dependency, but here the transitive dependency is there. How A determines B and B determines C. Obviously, A will determine C. To overcome this problem, we will perform some steps to remove the transitive dependency. That is, A is the candidate key. A, okay. To remove this A transitive dependency, we will create new relations. Our ultimate goal is to cut the relation between these two functional dependencies. Okay, because if we cut this relation, as I told, two separate relations, if it forms, then we should check the conditions for the two separate relations individually or separately. Okay, so therefore R1 of A comma B, R2 of B comma C. Now A is one key and B is one key. B is depending on A. Done. C is depending on B. Done. Okay. But here we should check individually. So therefore C is not depending on A. Hence it is free from transitive dependency. Hence it is in third normal form. Okay. If any doubts regarding these topics, you can comment in the comment box. No problem. I will clarify your doubts. Next, last and final form, that is boycott normal. This is most important and very, it will come for 2 marks in semester exams and more weightage in gate. Gate, it has more weightage. Okay, let's discuss. Okay, so it is an advanced or stronger version of third normal form. Okay, every determinant must be a so candidate key. As I told, A determines B and B determines C. Okay, these two are separate relations because transfer dependency is there. Now, what it is telling is every determinant. So this is determining, this is determined. Determinant means who is determining? A is determining B. So here set of A comma B are must be candidate keys. Okay, that is it telling. If we check one example, third normal boycott normal form is also called, as I told, 3.5 normal form. If we check third 3.5 normal form or boycott normal form, every determinant, here A is determining B. A should be candidate key. From our previous example, A is the candidate key. Okay, B is not. So here B is violating boycott normal form. So we should remove them, or we should make it from free from uh, this situation. That is, we will divide them into relations A of B and R2 of B comma C. This is the boycott normal form we should perform. Okay, we will check an important and most repeated example. This is an example from previous gate question. Okay. There they will give options, but we will perform from starting. I will give an complete overview as I told each and every normal form example. So I will leave for you how you will do, and I will give a rough overview. You comment the answer in the comment box. I will share this slides and PPT. The relation is R of A, B, C, D, E, F, G, H. These all are called as what? Functional dependencies. Okay. Obviously, the given functional dependencies are all are in first normal form, as I told previously, because all are atomic. Okay. Given functional dependencies, so perform already in first normal form. So perform second normal form, third normal form, and 3.5 normal form if we require to perform. So ultimately, if we perform all these steps, I may understand that you all are clearly understood my class. And if we perform all this, we get a normalized relation database schema, which is free from duplication of data or redundancy attributes or data. Okay. This is the concept of normalization, including these all types of normal forms. And once we'll go for conclusion. Okay. Coming to the conclusion of today's class overview. Normalization improves structure as gives a well-defined structure, as I told, makes database efficient by removing duplicates and redundant values. The database is more efficient. It will become. It gives clear, well-defined structure relation schema. As relation schema will give well-defined structure. Do not have spurious. Spurious means what? Duplicates. Duplication of data or attributes is not. So these are the points. These are the theoretical way of points. To achieve this, we perform normalization. What types? 1, 2, 3, 3.5. 4, 5 also there. Those are not much, but comment to world. These four are very most important. Okay. If anyone can't understand, please rewind the or please go to the previous videos, previous and from starting, revise from starting, see 3 to 4 times. Definitely you may get because I have told simple tricks for finding second and third normal forms. For those who understand, please do that example and comment in the comment box so that I will reply to your answer whether it is right or wrong. If it is wrong, I will make a separate video for that single question and I will explain clearly. Yeah. Thank you. Thank you for joining this class. Have a great day. Please like, share, and subscribe the channel. Thank you.